Welcome back to HANA Basics for Developers. So we've seen enough of the basic environment of SAP UI5 and how we can load it inside of XSA as a service broker. We learned a little bit about text bundles. I think we're ready to go on to creating a simple first user interface that interacts with the backend using OData services. So we'll start real simply here. But let's switch back over to the Web IDE and let's create another folder inside of our web resources there we are, there's my mouse, to separate each of these little example applications out from each other. So let's create an OData view, and then we'll just create a new index HTML. And I want to point out that there are wizards here. I mean, there's the Fiori Master Detail wizard. There's the and also the List Report module wizard. These are good under certain circumstances. If you're really trying to connect up and use an existing OData service, one of the things to keep in mind if you use one of these wizards, you have to turn off authentication on your OData service. So it means maybe changing the settings of the web module, maybe even unwiring your UAA temporarily to run the module wizard. And then it creates a whole separate module. It cannot go into our existing web module. So it would then mean taking that content and cutting it, pasting it into the web module. Still, that's something that I do sometimes. Many people do. It's a time saver to still use these wizards. For these exercises, I'm not going to use the wizards, partially because of that complication that I told you about having to turn off the authentication and things like that. But also, I think it's good to use a wizard as a time saver, but you'd always know what the wizard's doing and why it's doing it. So if you need to debug the application, to make changes to it, you aren't hopelessly lost. And if we become too dependent upon wizards as the only way to create content, that's really not a great situation. So for these educational examples, I'm going to start and we're going to code all these UI5 applications largely from hand. Now, I have a lot of templates that you can cut and paste from, and then we'll study the code. We don't want to spend a lot of time typing, but at the same time, we're going to pick through these piece by piece, and rather than let a wizard generate the whole project structure for us. So similar to our index HTML of just our little standalone application with one button on it, we're going to have a similar structure. You'll find most of the applications, if they don't, UI5 applications, if they don't run within the Fiori Launchpad, then they are going to have an index HTML that specifies the bootstrap and other settings that go into the bootstrap, not just where the UI5 libraries are and what theme to use, but you see a couple of other settings here. Preload the libraries asynchronously. Our default language is English, and we want our resource roots. What we're saying here is the real path is the relative path // so basically our OData view, but we want to have a resource kind of namespace, if you will, called OpenSAP.ODataTest. So anytime you see that, that's really just going to reference the root here. Okay. We see which libraries we want to load. Most of our core UI elements come from the .m library. You'll see us using layout and unified for some of the other UI elements as well. We're going to put a link in here to our generic error handler in this common folder. That's something that we loaded earlier for one of our example test applications. It's just got some generic error handlers that are nice, for catching bad response calls when making OData calls or when doing custom REST calls. So we don't have to code those in each event handler. We can reuse those. I also have this startup.js that was also loaded earlier. It's just got some built-in logic here that can go get session info like your username from the server and can load the shell. The shell, the unified shell, is the framework that that you'll see it here in a minute when I launch my application. It has got the header with the log off and the SAP logo and stuff like that. We're going to use this over and over again in many of our applications, standalone. So just using the same logic over and over again. Basically, then it initializes the UI framework to load within that shell. I also put it here in the index as a reusable startup script. That way, if I do later, you'll see some examples that we could run inside the Fiori Launchpad as well. And we have a test tool that allows us to simulate running in the Fiori Launchpad. Once again, I'll show that to you a little bit later. But by putting the initialization here in the index HTML, then it makes it easier to run the same application either in the Fiori Launchpad or standalone, as we're going to do here via an index HTML file. But the real, if you will, the real start to your application, this is sort of boilerplate startup code for the most part, other than the header stuff. The real start of the application is really our component.js. So we'll create another file here called component.js in the root folder of our application. And let's go get the coding for this. So the component.js is really something, this is where we could start. Oh, and I got a little extra garbage there. This is where the application could start up even if it were running inside of Fiori Launchpad. And basically what you see here is we're going to initialize the component. We say we're going to load most of the configuration for the component from a manifest. It's going to be a manifest JSON, which we'll add here in a moment. We don't have it yet in our application, but you'll see us load it here in a minute. We require a few libraries, the message box and the message toast library, so we have them available later. But basically then we call the component init, and then we have a destroy. This is pretty bare bones. All it's really doing is deferring most of the configuration, startup configuration, to a manifest JSON. Okay. Now let's create the manifest JSON in newer SAP UI5 applications. That tends to be where we do most of our setup and configuration of our overall application. It's to where we generally declare our resources, whether they be OData resources or language text bundles. We can do that all here in the manifest JSON in a more declarative kind of way, rather than coding a bunch of stuff in the startup script of our application or even in the component.js. So let's have a look here. Let's grab the manifest. And what you see here in the manifest, a lot of boilerplate code. I honestly, I ran the wizard once and got a base manifest, and I tend to copy it around then between applications. Or you can go to the help, the SAP UI5 help, and there's examples and some documentation on this as well. Basically, startup parameters, where it can go to find its I18N, its text bundles, some translatable text that we have in here for the title, the description, and what version of Fiori do we want to design against, what version of SAP UI5 is the minimum version that we're using, what are the possible themes. So this is all a lot of metadata that can be read by the Fiori Launchpad. For the most part, we're going to leave this alone. The main thing that we want is our root view. Which view do we want it to load initially, which we're going to create here in a minute. But that tells it basically where to start rendering. We're primarily going to use XML views. That's the recommendation these days. Once again, a more declarative approach rather than a bunch of JavaScript coding or HTML to design the user interface. That's good. And then the other thing here, we do create a JSON model. The root default model is a JSON model for storing some internal configuration and data. And then we do have a resource model pointing to I18N properties for text bundles, like we talked about in the previous video. We're not going to load our OData model here simply because we want to load it dynamically in the controller. But if you had a static model, we'll see later, an OData model, most of the time you would configure it here in the models. So we'll see some examples of that later. But for for these first couple of exercises, we're going to do some things where we load our OData dynamically. So as I said, it'd be in the controller JavaScript code rather than here in the manifest. Let's add our text bundle. So we'll come here and we'll add an i18n folder and then an i18n_en.properties file, just like we referenced here in the manifest. So that's how it's going to know to load i18n, English specific property text bundle here. And I've prepared a bunch of text for our application. Let's go get those. Nothing terribly exciting to see here, except we've taken and we've been good developers. We've created text IDs for all the different parts of our application, and then rather than hard coding them in the view, in the buttons, in the error messages, we'll use text bundles, and we'll do all this in a language translatable way. Even though I haven't offered any other language translations, it's at least set up and available for that. Now, just like we specified here, we want our start view to be in a folder named view, and then it's going to be app.xml. That's what we specified the manifest to tell the component to load initially. So we need to create that now. So we'll create a file, view /app view XML. Okay. And I've prepared the complete coding of the view, which we'll talk about after we get it in here. Not too fancy. So I'll just put that in. Basically, what do we have here? When you declare a view, we have to declare the libraries up at the top here and give them namespaces. So we're going to use the .m library, the main library in UI5, and the MVC library in the core. We specify what our controller name is going to be. It's going to be in a folder called controller, and then app, just matching up to the name of our view. It doesn't have to match up. I find it's easier to maintain applications if you use matching names there. It's obvious what it belongs to. We have a little bit of configuration here, height, and what CSS class we want to apply. We're going to do the UI size compact. We create a page, specify a title. Notice our text strings, our language text strings, we don't have to declare the whole bundle and load the bundle. Inside a declarative view, an XML view like this, we can just do the name of our resource, i18n / and then the text key. So once again, from the manifest, this is coming here, the name of the model for this resource, i18n. That's where it came from. It just happened to have the same name as our file, our properties file. It does not have to have the same name, but it's the name here. That's the name part that you reference here. And then / and then this is the text key, app title. So then it would come here and it would look up app title, and at runtime, the view will automatically replace it with the text, the language specific text for the bundle that you are asking it to bind to. Okay, that's good. Then we're going to create an icon toolbar, and in that toolbar, we'll have a filter, and we'll put a fragment in there. So a fragment is a way of breaking up your view definition or UI design into separate parts, both for readability and reuse, so that we don't get so many lines of code. I like to do this. I like to break up the different parts. If I get different panels, if I get different tabs, I tend to break those up into separate fragments just to help with the maintainability of the UI design. But it does mean that now we need to go create another view here. So we'll just create another file, and we're going to name this mread.fragment.xml. Let's go get the coding for this. So this would be the top part of our application with all of our input parameters. Basically, we're going to have an input parameter. And what this is going to allow us to do is call the OData service dynamically. We're actually going to be able to list the path to the OData service, and then the parent entity and the child entity in that OData service. We're We're going to have a button that when you press it, it's going to call the OData service, and we're going to have another button when you call it. It's going to call a custom REST handler to download the data in Excel format. All right, and then what we're going to want is two tables, one to hold the header data from the parent entity and one to hold the item data from the child entity. This is going to be a purchase order header and purchase order item, but we're going to do each of those in their own fragment as well. Once again, I could have done this all in line, but maybe we would have 100 lines of XML, which I think begins to become a little difficult to read and maintain. It's much easier if we break these out into fragments. So let's create the first fragment here, the M table head. So new file, M table head, fragment XML. And we'll go get the code for it. Here I'm just going to create a vertical box just to give it a scrolling alignment area. And then I'm going to use the smart table control. Right now I'm just putting the control out there as a table. I'm setting the header, a few other parameters. I'm not binding it to anything yet because I'm going to load my OData dynamically. I'm also going to bind the OData to my table control dynamically in my controller logic as well. So we're starting off here with a much more dynamic process. Of course, could have bound all these things at design time in the definition within the XML. That's sort of the easy way to do things. Let's go with a bit more advanced, learn a bit more advanced way, and then we can always back up and do things easier later. So let's take the item table and create a fragment for it. And let's go get the source code. And it's basically the same thing as the header. I'm going to create a smart table control with a different ID so that we can bind our other entity to it. Okay, we'll save that. Now we're going to need the controller, which in the case of our application, it's going to have a fair amount of important logic in it because we're going to call our OData service in it, define our OData service, I should say, or connection to our OData service, and we're going to bind to our two tables. So let's go ahead and create this in a folder called controller, and then app.controller.js. Go get our coding. And what we see here inside the controller, there's different event handlers. When you came in here, this would be all pretty empty, but the main one, the on init, is a built-in event handler. It's when the corresponding view gets initialized. So this is when we're going to do things like put defaults in the screen. That's actually what we're doing here. Is remember we had over here in our very first app. In our mRead fragment, we have input parameters for the path, the entity 1 and entity 2. I'm actually going to use the controller to set default values in there. XSODATA, purchase order.xsodata, PO header, PO item. We bound our UI elements to the model. So inside our logic, we don't directly write into the screen. We simply change the values, we set the properties of the model, and that will reflect in the screen. Vice versa, when we want to get the values out of the screen, when somebody presses the button to call the service, we do the same thing. We get access to our model that's bound to our screen UI elements, and we use the get property. And that's going to get us the current value. Then what you see here is we're going to set some parameters for calling the OData service. I'm going to initialize an instance of my OData service, dynamically giving it the path and the parameters. So the path will come out of the screen. And then we're going to attach an event. If the request fails, we want an event handler so we can log that, throw an error message to the user. But then what we want to do here is we want to have a function that will load the metadata of the OData service. And really what we want to do here is we want to read the metadata of the OData service and use that metadata. Remember that $ metadata when we call the OData service, that's going to tell us all the columns and all the data types. We're using that to dynamically build our user interface. So I'm building the columns that I'm going to want in my header and item tables by whatever columns that I see in the metadata that's coming back from the OData service. So I'm building my user interface totally dynamically. This is it's really kind of a blank user interface. I'll show you here in the preview in a second. It adapts to really whatever OData service that you would give it. So it's a pretty powerful UI here. So this logic to load the metadata, we attach the event of the model that says once the metadata is loaded, then call this function that will process that metadata and use it to define our UI. And of course, we also have if the metadata fails, we want to throw an error message as well. Something went wrong. Finally, what we have here is the call to Excel. It's basically just going to call our Node.js service that use the Excel npm module. It's going to transform the data to Excel, and then it's going to give it back to us. We'll see what it download when we click on it. Okay. So I think we're nearly done here. Oh, I do need a base controller. It's just some inherited features of the controller. There's another thing that I tend to copy around. The templates will generate for you, and they don't really have to be altered too often. So just some nice reusable functions here to get the router, to get the model, to set the model. So we'll just grab those, and then they'll be inherited. Oops. Inherited into our controller. See this base controller. If we look at our app controller, we said that we inherit from the base controller. That's where we're going to get those functions from. Let's see what else we need. I need a bunch of model helper libraries, and this is another thing that I got from the wizards. I generated the wizard once, and I tend to copy around between applications. So we just go download that. I made it available here, so we don't have to run the whole wizard to get it. But model.zip. Download that. And then come here to our OData view. Import. And we want to go into folder named model. There we are. And if you want to look at these, you can kind of study them on your own. They're just helpers for formatting currency columns, to do grouping, group sorter in here, and then a base model object with that preloads some information about models. Like I said, not directly impactful to your application logic, generated by the wizards if you were to run the wizards, but like I said, I tend to copy them around between applications. Just before we run this, and I show it to you here, what we can see is if I come back to the view and look at the app view, let's look at it in the layout editor. This is nice. It's kind of showing us what it's eventually going to look like. Oh, did I leave Japanese? I'll have to go check my browser settings. I think from the previous video where we set we were testing the text bundles, I might have left my browser in Japanese there, which is why we're seeing some Japanese. But we get the overall look of our application. We're going to have an application title on the whole page. We're going to have an expandable panel here. with our 3 input fields, our 2 buttons, one to call the service and one to download to Excel, and then our 2 tables. We're going to bind the 2 entities from our OData service too. Okay, so that looks good. Looks like what I'm wanting. Go ahead and close all these. And in fact, while I'm thinking of it, let me go check my browser settings and change that back from Japanese. Yep, I did. I left it Japanese. So let's set that back up to English there. And now let's run our web module. Now, if you run the web module, it's still going to come back to our index.html. Find my mouse. There we are. It's going to come back to our index.html. We could, of course, manually change the URL like we've done with all of our other testing. We name this OData view. So OData view, and it's going to run our application. Oh, and I must have done something wrong there with my text string. It did not pull in my text bundle correctly. So you see what that looks like. I18n, I18n underscore en dot property. I've got a misspelling here. See how easy it is to make a little error? Just a misspelling on the file extension, and now it can't load my my text string properties. Now that I've corrected that, let's rerun the web module, pick up the change, and refresh our UI. Yes, that looks much, much better. And what we see here is we defaulted in XSODATA, purchase order, XSODATA, PO header, PO item. If I run the service, there we go. It's called the OData service. It's taken the data. It's bound the header data into one table control, the item data into another table control. This smart table control is pretty nice. We've got client-side scrolling here. We can hide columns if we don't want. Very configurable. We can add sorts to the columns. Maybe we want to sort here on sort on product, maybe ascending. There we are. We added a sort in. It's got built-in export to Excel in it. That's really nice. We can expand, and of course not many records there, but maybe this one would be a nicer one to expand. So the smart table is really nice and robust. We also see here we can click the download to Excel, and now we're calling our custom OData, not our custom OData, our custom JavaScript Node.js RESTful service that would export the data to Excel, all from our user interface. And if we were to come here and look at this in the developer tools, let's refresh here. Of course, it's loading all of the website itself. If we look, and of course it did not call our OData service because we're loading it dynamically at runtime when we press this execute service button. When I press that button, you see it's going to make a call first to the $sign metadata, and it's going to get the metadata of the OData service. That's how it creates these columns that we see here, and then it's going to make a call. We actually see a batch call to the service to go fetch the data of both the header and the item, and then they're bound to the 2 different tables that you see here. And I've only got 20 records, so I think even as I scroll here, it's all cached on the client side. But this smart table control is really nice in that if I'd had much more data, and we'll see that with a few subsequent videos, it only bring down a chunk of the data, a little bit more than what would be visible on the screen, but not all the data. And then when you need more data, it will call the OData service and it use a top skip. Those are URL parameters they can pass to the OData service to say, all right, I'm already 100 rows into the table, give me the next 50. and that will be passed all the way down into the query inside the database, so to only extract that subset of the data. So it's really efficient, particularly when combined with HANA. We're not having to pass tons of data back to the client side, but we still get a very rich user experience, as though it was almost a fat client with all the data down on the client side. So you really get a great experience with a loaded data transfer kind of scenario there. So I know this is a pretty robust application. We're doing things dynamically here. I'm loading the OData dynamically, but that's because I wanted to teach you more about what's going on behind the scenes with the OData service, be able to point it out, how to load it, how to do it dynamically when you want to. Of course, most applications probably define it statically in the manifest. We're going to see that a little bit later. Once again, I like to teach you the fundamentals behind some of these things before we go with the little bit of the easier route to do some of them. So don't, hopefully you aren't feeling overwhelmed by anything that we've done here so far. We will back up now and see some of the more common, simpler examples now that you have the fundamentals of working with the OData within SAP UI5.